This is the last summative of the trimester, and it is going to cover equations and functions. It will be worth 50 points. So even though it is worth 50 points, there are 19 questions. So in reality, every question is going to be worth a certain different amount of points. The first part is going to discuss the idea of graphing and choosing graphs for specific situations.
Are we supposed to write this down?
These are going to be worth 1 point each.
How many points?
And there are two questions similar to this. So if I was to give you an example, so which of these graph would best represent the situation of the basketball being thrown, missing the hoop, and then bounces very high and slowly keeps bouncing until it stops? Well, based on the situation, we would probably say B. So there will be two questions like this. Each question is worth 1 point. There will be one question, and this one in total is worth 3 points because the table is going to be worth 1 point, the graph is worth 1 point, and the mapping diagram is also worth 1 point. So let me give you an example of the relation. Let's say I give you the following relation: 4, 7, 2, -3, 1, -5, and 0, -2. If I asked you to express this as a table, as a graph, and as a mapping diagram, you will be given the 3 prompts so that you remember what is what. So they'll tell you what the table looks like, what the graph and label, make sure you label X and Y axis and everything, and the mapping diagram. So the first thing you would do would be to remember that when you are listing the relation in a table, you keep the X's with their respective Y's. So the first point is 4, 7. The next one is 2, -3, 1, -5, and 0, -2. That is the table. The graph is literally plotting the points. So you would go 4, 7, which would be up here, 2, -3, which would be right there, 1, -5, and 0, -2. So this is using it for a graph. And mapping diagram. What must I remember for mapping diagram? Right. Your job is to make sure you're properly labeling the fact that the first group is domain. You must write the word domain. You must write the word range. You must then, from least to greatest, so the domain, if we're looking at it, from least to greatest is 0, 1, 2, and 4. And the range from least to greatest is -5, -3, -2, and 7. And then your job is to draw arrows from the domain directly to its corresponding range. So 4 goes to 7, 2 goes to -3, 1 goes to -5, and 0 goes to -2.
Does it have to be?
That is that specific question. Nothing fancy, nothing necessarily trying to trick you or anything of the sort. It's very straightforward. All right, so that was the second part of the test. The third, or let's say third type of question, not really part of the test. The third type of question is going to give you a table, and it's going to ask you to give the domain and range of the relation. And then if I asked you to give the domain and the range, correct, the way you would write it is you need to remember proper format. When you're writing in proper format, please do not forget, you're going to write D for domain, open brace, and from least to greatest, 0, 1, 2, and 4. R for range, open brace, least to greatest, -5, -3, -2, and 7. And that's it. That's all you have to do for listing the domain and range. This one is also worth 2 points. 1 for the domain and 1 for the range. There is one type of these questions.
How many questions?
Now there's another one that is going to be similar, and that one is going to be the following. The fourth type of question is actually worth 4 points because there's 4 parts that it's going to be asking you for. It's going to give you a graph, which I'll show you in a minute, something similar. It's going to ask you to give the domain. It's going to ask you to give the range. It's going to ask if it's a function and why or why not. That's the 4 points right there. So let me give you a couple of choices just so that you guys know every type of possibility. So I'm giving you 3 different situations just to best prepare you for the summative. If I asked you for the, and I'm actually going to erase the arrowheads on this one for a specific reason. If I asked you to give the domain and the range of each relation, remember each of these 3 is completely independent. For the first one, let's call this one A. What is the domain? Now I have to label it a little bit better. So let's look at the very first one. And I know that the very first one is, let's see if I can get it perfect. So if we're looking at this one here, what would the domain of that relation right there be? Well, we know that domain means what?
X on X.
It's on the X. So we're looking at our X values. We want to see the depth of how much is within our X's. However, please take note. You see those arrowheads, or what they're supposed to be arrowheads? It means it goes on forever. It goes on forever. So if I had to tell the reader where the domain or what X values are inclusive of this graph, what would they be? Direction. This graph is going on infinitely forever in this direction. So that's, all of those numbers are going to be part of the answer. Where does it begin with the X's?
So
7.
At 7.
Or less than 7.
Exactly. So in this case, the domain is going to be the X values that are less than or equal to 7 because it's from 7 and everything less. Because the arrowheads told me I go on forever. That's X. That's domain. What about the range? What is my range of Y values that will be part of this graph?
Would that be like the...
We know that the Y's are limited between 4 and -3, correct?
Yeah.
Now, at the same time, if we really wanted to be theoretical about it, and this is not the one that's on the summative, but I want you to think about it, 4 and -3 are just here, but this is infinitely getting bigger in all directions, correct? So in reality, it's going to be everything. It's going to be every value of Y, because even though right now it seems like it's limiting at 4 and -3, if I keep on going forever in this direction, it's going to be all real numbers, because every number is going to be a solution within it. Now, I'll tell you right now, that is not like what's on the summative, but it's important for you to see that this is more of an Algebra 2 concept. We are talking about my domain, which is my X values, and it's really from 7 on forever. And my range, which is my Y values, at first I think it's between 4 and -3, but if I remember that the arrowheads mean I'm opening up infinitely, upwards and outwards, it's going to be all real numbers in that case. Now let's look at the next one. This one here, please take note that there is no arrowheads. There's no arrowheads, are there? That means it is not going infinitely forever. So based on the fact that there are no arrowheads, what are the domain, or what is the domain? Remember, domain is the X value. I am between -2 and 4, correct? So your x value is between -2 and 4, and we remember that when we're in between, we use the less than symbol, and it is part of it, even though I erased it as I was drawing it. This here was supposed to go up exactly to -2. So -2 and 4 is my limiting points. That's what my x is limited to. What about the range? Well, looking at the range, I'm going to look at the fact that, again, when I zoomed out, it sort of threw this off. Let's say that this is -4, okay? And this is 4, yeah. What is my range going to be?
Less than or greater to 4.
Yes. So my highest point is 4 on the y. The lowest point is supposed to be -4. So exactly right. My y, now I change from using an x letter to a y letter, is going to be between, if we look at this and we look at this, it's supposed to be between 4 and -4. -4 and 4, less than equal, less than equal. Part of my range. That was muted, so let me just repeat what I just said. This is going to be all reals because it's infinitely going outward more and more and more. So every value of x is going to be a solution or part of the domain. And with the range, the highest point is the 4. That's the highest. So that means all my y values are going to be less than or equal to 4. Now the next part is going to ask, and I purposely did this out of order, but I want you guys to see. Tell me, for the first one, for this one here, is this a function? Yes or no, and why or why not? No, it is not a function. Why?
Because the points range has.
You know the domains repeat because of what we call the vertical line test. So the vertical line goes through more than one point at a time. Therefore, the domain repeats and it is not a function.
That's
Saying is, the vertical line test says that if you go through more than one point at a time, so if you look here and you look at that vertical line, it's going through this point here and this point here. So in reality, this point here could be like 3, or let's say this is 5. 5, 3, and this one is 5, -3. 5 and 5, you've got an x value at 5 here and here. 5, something, 5, something. That means your domain is repeating. So the vertical line test says that if you have a graph, a picture graph, if you draw a vertical line and it goes through more than one point at a time, it means that there's a repeating domain, which means it's not a function. So with this one here, if I was to draw a vertical line once more, does the vertical line go through more than one point at a time? No. So it therefore is a function. Yes, it's a function because the vertical line goes through only one point at a time, meaning the domain does not repeat itself. So what if I tried the vertical line on this guy over here?
That's a function.
It is a quadratic.
Yeah.
Is it a function? Yes, it is, because it's only going through 1 point at a time. So this part here doesn't go through more than 1 point. Remember that it's infinitely increasing, widening itself. So I am only going through 1 point at a time.
Can you go back to the first?
So in this case, it's the same exact thing. Yes, it is a function because the domain is not repeating. And the reason I know it's not repeating is because that vertical line does not go through more than 1 point at a time. Unlike this one here, where a vertical line goes through 2 points at a time, here and here, or infinitely, any 2 places there. So that is why it is not a function.
Wait,
This one is very similar to the one we just did, but the difference is that, so they're going to ask you for the domain and the range, whether it's a function, and why or why not. The difference is that instead of showing you a graph, it's going to be a mapping diagram. So you might have something that looks like this. Is this a function?
yeah.
Yes. How do you know? Well, none of the domains repeat. In other words, the domains are attached to only one range. 7 only goes to 3. It doesn't go off to anything else. 8 only goes to this. 9 only goes to this. 11 only goes to this. So if I asked you to also list the domain, you would be able to just literally list it, 7, 8, 9, 11. And the range would be -5, -4, 3, and 2. And that's the 4 points right there. Now, let me give you an example of one where you would hopefully be able to recognize that it is not a function. Looking at this graph, this mapping diagram that you see right here, hopefully you will recognize that this is not a function because what domain repeats?
9 goes to -3.
Exactly. So this is not a function, and you can abbreviate function F parentheses N. That's how I do it, because I'm lazy. Because the domain of 9 repeats to 2 different ranges. And those are -3 and -2. And again, if I wanted to list the domain and range for that, it would be very simple because it's already in order for me. So I would just write 7, 8, and 9 for the domain. And the range is -5, -4, -3, and -2. Rules and stuff. All right. The next type of question, the 6th type of question, which of the following relations is not a function? And it is a 2-point question. This one will be multiple choice. It's going to give you a list of relations written as ordered pairs, and your job is to tell me which one is not a function. So as you look at these 3 choices, A, B, C, or D, which of the following relations, now remember a relation is a group of ordered pairs, so that's a relation, this is a relation, and C is a relation. Which of these 3 would not be considered a function?
B.
Which one?
B.
B. Why?
Because the domain repeats.
Which domain? Yeah, the 5. We've got 5, 8, and it gives you different ranges, and 5, -4. So this one is not a function. If you think about the function machine that we kind of made, if you put an input of 5 and you get the output of -4, and then you put the input of 5 again and you get an output of 8, it's not working. There's something wrong. So this is not a function. Now, the question was, is A also not a function? Let's look at the domains. Remember, in order to be a function, you look only at the domains. 5, 7, 3, 2. No repeats. This was a trick one. The range repeats, but that doesn't mean you're not a function. Only if the domain repeats is it not a function. So looking at this question, remember we said that these are going to cause a little bit of disturbance in our force. It's all right. You try to figure out what it is. How did I get to -5 from -1? And it's the same process that I got -2 from 0. If you don't see the pattern, I recommend that you remember it's going to be y equals something done to x, and then you're going to do something else. So what we had said is if you list it, if you list them like vertically, x's and y's, sometimes it'll help you. If you look at what happened between this and this number, what happened? You, from -5 to -2, you added 3. From -1 to 0, you added 1. Change of y, which is 3, over change of x, which is 1, that gives you 3. That's the number that goes here. Once you have that, then you just trial and error. Pick, I don't know, 0. 3 times 0 is 0. How did I get to -2? Oh, you must have minus 2 from that. And then if you try it with 3, 3 times 3 is 9, minus 2 is 7. 3 times 2 is 6, minus 2 is 4. So that's the trick of figuring it out, is looking to see what happened, change of y over change of x, and that's the number in front. Otherwise, it's just trying to recognize it. The next type of question, which is question type 8, is worth 3 points, and there are 2 questions like this. So you will be asked to look at the question and identify the dependent and the independent variable. I think you guys are pretty strong with these. Let's look at the equation, the question. Bless you. Then afterwards, they want you to write an equation in function notation. Please remember that function notation is at f parentheses x. So looking at the question, it says, Bill charges $4 per notebook. What is the independent and the dependent, and what is the function notation? Well, we know that we're talking about Bill charging money per notebook and that he makes a total amount dependent on how many notebooks he sells. So that means that the dependent amount is the total amount of money Bill makes. He makes a total amount of money that depends on the independent, which is the number of notebooks. And what would my equation be in function notation? F of x is equal to, it would be f of x, which could be the same thing as saying y equals. So the total amount of money he makes is equal to what? The total amount of money he makes is going to be 4 multiplied by the number of notebooks. So there's 2 questions like this. All right? So you plug in -3 in for x, and you get the function of -3 by actually multiplying 7 times -3, which is -21, minus 3 is -24. So the function of -3 is equal to -24. Then you go ahead and do it for the next one. they want to know what is the function of 2. And your equation is still 7 times x minus 3. So you're going to plug 2 in for x. 7 times 2 is 14. 14 minus 3 is 11. And therefore the function of 2 is equal to 11. So the next question, which will be the last one we'll be completing today, and we'll go through the rest tomorrow, they want you to graph for the given domain and then name the graph. They're going to tell you the domain. So they're going to say the domain is -2, -1, 0, 1, 2. They'll tell you the values of x. When they ask you to graph it, they basically are asking you to plug in that value of the domain into the equation to find out what y is equal to, and you have the points. So you would write -5 times x plus y equals 3, where x is -2. So if I was going to be calculating the math, doing the math part of it, you would get -5 multiplied by the -2 gives you 10. And so then you get 10 plus what is 3? Subtract 10 on both sides, you get y is equal to -7. So your first point would be when x is -2, y is -7. And you keep on completing the range values so that you can then get your plotted point. Okay, so this one, -2, -7 is the point. Let's do the next one. The other way that you could have looked at it, and I'll just quickly overlap it this way to show you, if you have -5x plus y is equal to 3, if you want to know what y is equal to, you could use your knowledge of solving literal equations. Remember when you transformed equations? Yes. And you can add 5x to bring it on the right. And you would get y is equal to 3 plus 5x. That formula or that equation might be much easier to work with when you're trying to calculate the y values. If you know that the equation is y equals 3 plus 5x, and we know that's the same thing as the original one, it's just that I transformed it, that in order to get the answer, you can say, well, the y is going to be equal to 3 plus 5 times x, where now we know x here is -1.
Yeah.
That's going to give me 3 minus 5, which is -2. So when x is -1, y is -2.
Yes.
You do not have to transform the equation into y equals, but it probably would make it easier if you recognize, let me just get y equals. If you did not solve the equation into y equals, you would have used the original equation, plugged it in properly, and then just solved for y. So it's either or, up to you whether you want to transform the equation into y equals to get the correct value, or if you want to leave it as it is. For the next one, let's just use the y equal to now that we have it. We know y is going to equal 3 plus 5 times x, and x happens to be 0 here. 3 plus 0 is 3, so when x is 0, y is 3. Okay, next one. 3, then it's 3 plus 5 times, well, now we're going to substitute 1 in, and that's going to give you 5. 3 plus 5 is 8. 1 comma 8 is the next point. And then the last one is going to be 3 plus 5 times 2, and 5 times 2 is 10, and 3 plus 10 is 13, so when x is 2, y is 13. So the first thing that I've done is I have created a table of values that have then created proper ranges for the given domains. So if I wanted to graph it now, which is what the question is asking me to do, I would just refer to the points. I would have a graph. If I am going to graph those points, you are going to have your own graph. It's going to be given to you, so all you have to do is just plot the points. -2 comma -7 is right here. -1 comma -2, 0 comma 3, 1 comma 8, 2 comma 13 is like right above here. We connect the dots. And the question, if you referred back to it, asks not only to graph it, but name the graph. What kind of a graph is this?
Continuous.
Linear. It is continuous, but we're going to write linear because that's what they want.
Linear.
Linear. Remember the different types of graphs.
I don't remember. Quadratic.
If you have, yep, this is linear. If you have an equation and it graphs it like a U, that is a power of 2, which is called a quadratic.
I knew that.
If you have an equation where you graph it and it makes a V, that is absolute value. And if it makes a line, it's called linear. Now I gave you a separate one. It is asking you to, same thing, it's asking you to graph and then name the graph. So if you think about this, what this is asking you to do now, given the information that is here, it's not giving you a domain, correct? So what happens when I do not get a domain given to me?
We can make them up.
You have to make it up. Very good.
I know, like.
So when you make it up, can you make up any numbers you would like?
Yes.
Yeah.
Yes, you can. Remember, whatever numbers you choose for your x values, whatever numbers you choose, when you plug them in, you're going to, if you properly did the math, you're going to get a corresponding output for that specific input that is going to be related in the same way as anybody else's outputs to their specific inputs. So the graph you get is going to be the same graph as the graph I get if I chose different inputs. An error. Please, you guys, I've tried from the moment that I've been teaching you, whether it was in pre-algebra and algebra, to always remind you that when you are plugging things in, that you make sure that you rewrite with parentheses first. Because if there's any negatives that are part of the group, when you go to multiply by negatives, you might make an error. So from the very beginning, I want you guys to see that what you're going to do is you're going to plug things into negative 2x squared minus 1, where if you think about it rationally, this is really negative 2 multiplied by whatever x squared is, and then minus 1. So rewrite it with parentheses first. And by that I mean to replace the variable with a parentheses so that then you're going to follow the correct order of operations when you plug in whatever value you choose for the domain. Some of you guys are already in the whole idea of, you know what, I'm always going to just choose the same values. I'm just going to always, if I get to choose my domain, I'm just going to choose my values. And some of you guys might choose negative 2, negative 1, 0, 1, and 2. That's absolutely fine. You can choose that if you like. Once you have that, you plug them in. So let's say negative 2 goes here. Order of operations, PEM does. You have to do exponents before multiplication. So you're going to do the negative 2 to the power of, so it's negative 2 to the power of 2 is 4. 4 times negative 2 is negative 8. And negative 8 minus 1 is negative 9. So when x is negative 2, y is negative 9, and that goes right here. If you plugged in negative 1, negative 1 squared is positive 1, because negative 1 times negative 1 is 1. That 1 times the negative 2 is negative 2, minus the extra 1 is negative 3. So when x is negative 1, y is negative 3. Plug the 0 in. 0 squared is 0, times negative 2 is 0, and 0 minus 1 is negative 1. When x is 0, y is negative 1. Plug the 1 in. 1 squared is 1, times negative 2 is negative 2 minus 1 is negative 3. When x is 1, y is negative 3. You're noticing that it's already starting to do that little curve down.
Yes.
Plug in the 2. 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 minus 1 is negative 9. When x is 2, y is negative 9, which is right here. Now, you may look at it and go, oh, that looks like an upside down V, but it's your job to remember, that's right, power of 2 makes a U, whether it opens up or down. So when you go to graph it, you just have to make sure that with your pencil, you carefully curve it so that it looks like the curve that it's supposed to be, as opposed to the V, which would be implying that it's absolute value. What is this called? A quadratic. The graph is quadratic. The shape is a parabola. But you will just leave it as quadratic. That is all you need to write for your answer. So when you have this, it's asking you, let's say it's asking you to find the value of y when x is 2. Well, what you're going to do is you're going to look at what y is equal to when x is 2. So when x is 2, you're going to be, so x is 2, you see, this is 2, you're going to go all the way down, and you're going to notice that the value of y when x is 2 is negative 10. So for this specific graph, when they ask you, and again, I changed it so that it would say 2, they're asking you what is the value of y when x is 2. Well, if you look once more, when x is 2, y is equal to negative 10. So your answer would be y is equal to negative 10. The other way you could have done it, which was absolutely correct, if you didn't want to even look at the graph, if you want to know what the value of y is when x is 2, then you can say, well, y is going to equal negative 4 times, I want to know what x is 2. Negative 4 times 2 is negative 8, minus 2 is negative 10. Y is equal to negative 10 when x is equal to 2. So there's two different ways you could do it. You could either look at the graph and go, when x is 2, y is negative 10. Or you could say, well, when x is 2, plug 2 into the x and figure out what y is equal to. If I ask you to identify the correlation between these three, and I know that it's not a very good picture, but imagine that this is properly x and y, and let's say that we just discuss, I don't know, whatever, temperature and time of day, or can you tell me the first graph, what kind of a correlation is that called?
I can't really tell.
A scatter plot.
It is a scatter plot, but what is the correlation? If we're looking at this, as time increases, temperature increases. What kind of a correlation is that? This one, because as time goes up, temperature goes up, this is called a positive correlation. What about the middle one? There's no correlation. They're just scattered all over the place. So there's no correlation. What about the last one?
Negative.
That's a negative correlation. So remember that when you're looking to see what the correlation is, a correlation is like a relationship. So they're asking you, what is the relationship between the two variables? For the first one, as time increases, temperature increases, that's positive. For the second one, there's no relationship, so it's called no correlation. And for the third one, as the time increases, as time goes up, the temperature decreases, which means it is a negative correlation. So if we look at this, in which situation, in which of these three situations would the correlation be negative? So what is it that we want for a negative correlation? As one goes up, the other goes down. That's a negative correlation. As one goes up, one goes down. That's negative. A positive correlation, if you remember, is as some goes up, the other one goes up. So positive means they both are going either up together or they're both going down together. So a positive correlation is they both go up or they both go down. If one goes up and the other goes down, that's a negative correlation. Which of these would be considered a negative correlation?
C, because if the temperature outside gets hotter, the snowball will melt, and as the temperature increases, the snowball decreases.
Exactly. Very good.
Yep.
What would this one be? The temperature on Saturdays?
Make it higher.
It would be
No.
No correlation. There's no correlation between the day of the week. I mean, it depends on the weather. It doesn't depend on the day, right? What about this? The amount of water in a pool as it rains?
Positive.
Positive. Very good. So, in the situation that we're looking for, which is negative, as temperature goes up, the size of the snowball goes down. With the water, as it increases, as the amount of water, or as it rains, the amount of water increases. Now that would be positive, and this one would be none. The last type of question on the summative, or for this unit, the last types of questions, there's two of them, is asking you about arithmetic sequences. Now, if you remember what the word arithmetic sequences is referring to, arithmetic sequences is like a sequence of numbers that are related to each other by a common difference. You're adding something or subtracting a common difference. We said that the very first number is what we refer to as A1. That's my first number. And we said that the letter N is what we use for the number of items. Number of items, or like for example, this one is number 1, this is number 2, and this is number 3. So if I said to you, determine if the following is an arithmetic sequence, and if so, find the common difference and the next three terms, let's give you one. Determine if the following is an arithmetic sequence. If it is, then find the next three terms and the common difference. And the last type of question, so just so you know, this question up here for the arithmetic sequence, this one is worth 3 points. The first point is going to be whether it's yes or no, and then the three terms, so that's 3 points. And then the second question, the last question of the test, is actually worth 4 points. And you have to find the 74th term in the arithmetic sequence that's listed. So for the first one, if we look at the question for the first one, they're asking me what the next three terms is, if it's an arithmetic sequence. Well, I noticed that from here to here I minus 3, and it's a continuous, constant, common difference. I am minusing 3 to every term. That means that the next three terms are going to be, well, negative 8 minus 3 is negative 21. Negative 21 minus 3 is negative 24. And negative 24 minus 3 is negative 27. Those are the next three terms. Yes, this is an arithmetic sequence because the common difference is negative 3. So for this question, they asked me what the next three terms are. That's really easy to just go minus 3, minus 3, minus 3. For this question is asking me for the 74th term. That's a long way down the road. I'm not going to write 74 different numbers. In order to do this question, many of you guys are like, what's the formula? Remember, it's great to memorize formulas, but it's even greater if you can understand how to do it without memorizing, because you never have to worry about it. Think about it rationally. If I have 74 items, and I kind of showed this example a little bit ago to Josh with my hand. If I have, that's a horrible hand, but I have 5 fingers. If I am going from one to the other, there's 4 spaces, correct? There's 4 spaces between each finger.
Toes or hands?
That whatever you want it to be. There's 4 spaces between each. That means that for 74 terms, there's 73 spaces. 73 spaces. That means I am going to, in this case, from here to here, I added 5. Same thing. Notice that I'm adding 5. That's my common difference. The common difference is that you're adding 5. Now, they're asking for the 74th term, which means that there's 73 times that I'm adding 5. 73 times 5 is the total amount that you are adding to the original number, which was -3. That is going to be -3 plus 70 times 5 is 350 plus that's 365. And that's going to be 362. That is the 74th term. If you wanted the formula, you could derive the formula from this same thing. 73, how did I get 73? It's n minus 1 multiplied by the common difference added to the first term. That's the formula. It's 73, which is n minus 4. N is 74. So 73 multiplied by the common difference. And that is being added to your first term. And that is being added to the first term. So you would say A of 74, the 74th term, is equal to 362.